So here we go. This is day 2 of linear programming. How do we apply this linear programming? How do we take this linear program to the next step? How do we look and how is this used in a real life situation? So in your course pack on page 305, we're going to do this example. It takes up the entire page. So hit pause, get your course pack out, page 305, and then we will continue. Example, an office manager is purchasing file cabinets and wants to maximize storage space. The office has 60 square feet of floor space for the cabinets and $600 in the budget to purchase them. The cabinet A requires 3 square feet of floor space, has a storage capacity of 12 cubic feet, and costs $75. Cabinet B requires 6 square feet of floor space, has a storage capacity of 18 cubic feet, and costs $50. How many of each cabinet should the manager buy? We are looking for, this is linear programming, so we want to maximize or minimize something. I want to write and kind of think about what my objective function is talking about. My objective function wants to maximize storage space. Okay, so I'm talking about storage space. I'm talking about cabinets of holding storage. Everything that we're talking about here is dealing with cabinets. So my variable x is going to be the number of cabinet A because I have 2 different types of cabinets. X is the number of the first one. Y then is going to be the number of cabinet B. Okay, so the big thing that I want to come up with is my objective function, maximizing storage space. Once I have that objective function, I can talk about my constraints. But what is my objective function? Well, as we've been saying, my objective function, we usually use C, but since we're talking about space, this is going to be S. S is my amount of space. Well, how much space? What is talking about space? Well, I have a storage capacity of 12 cubic feet in cabinet A and a storage capacity of 18 cubic feet. Sorry, a storage capacity of 18 cubic feet in cabinet B. That's storage space. So my objective function is going to say S is equal to the 12 cubic feet of storage space for cabinet A plus 18 cubic feet for cabinet B. That is my objective function. That's the first thing I have to figure out. What do I want to maximize? I want to maximize the amount of storage space. So that's 12 cubic feet times the number of cabinets X, 18 cubic feet times the number of cabinets B. How am I limited when it comes to my purchasing my cabinets? What limits my cabinets? Those are my constraints. So my first constraint, let's go ahead and talk about money. So my first constraint says I have $600. That's one part of my constraint. Cabinet A costs $75 and cabinet B costs $50. So one of my constraints tells me that I can purchase up to and including $600 worth of cabinets. My cabinets A, which are X, cost me $75. So this is 75X. My cabinet B, which is Y, costs me $50. Make that a little nicer, Y. $50. So there's my first constraint. I want my $75 times the number of cabinet A plus $50 times number of cabinet B has to be less than or equal to the amount of money I have budgeted. So that's my first constraint. I can't spend more than $600. I know the price of the two types of cabinets, so it has to be less than my budget. That's my first constraint. My second constraint is talking about floor space. How much space do I have to put these cabinets down? I'm going to do this in red. I have an overall storage floor space of 600 square feet. Excuse me, 60 square feet. Cabinet A requires 3 square feet of floor space, and cabinet B requires 6 square feet of storage space. So I cannot go over that 60 square feet. So I need less than or equal to 60 square feet. Cabinet A, we just said, was 3 square feet, so that's 3x. Cabinet B, we said, was 6 square feet, so that's 6y. And that's my second constraint. I'm going to scoot that down just a little bit. So again, the constraint comes from the fact that I can't have more than 60 square feet. I know I need 3 feet for every cabinet A, 6 feet for every cabinet B, so there is my second constraint. If I look through this, I realize that's all the constraints I have. I don't have any other built-in constraints. I do need to remember, realize, and understand that I cannot have a negative number of cabinets. So even though it's not stated, I kind of have something set up in here that says, well, x is greater than or equal to 0, y is greater than or equal to 0. I'm limited to quadrant 1. Why am I limited to quadrant 1? Because I can't have any negative number of cabinets. Now, am I going to go ahead and list that there? No. But notice in this graph that I put here, I'm limiting it to quadrant 1, and that's kind of the understanding we need to know. By the way, I'm actually throwing in x is greater than or equal to 0, y is greater than or equal to 0. Because we're talking about real life things, these two are always going to be thrown in for free because I can't have a negative number of things. So those are my constraints. And let's see what I can figure out. If I come up to my green constraint, let's go ahead and figure out what coordinates I have so I can plot this. If I plug in 0 for x, I'm going to get 50y equals 60, divide both sides by 50. I get my y-intercept to be 12. If I go ahead and plug in 0 for y, 75x is less than or equal to 60, divide both sides by 75. I get my x-intercept to be 8. So those are the 2 points for my green line. So let's plot those 2 points. 0, 12 is going to, wrong color, this is the green line. So there's 0, 12. And then my other point is 8, 0. So there's my second point there. So I have my x-intercept, I have my y-intercept. Let's go ahead and get a green line and draw that line of constraint. 75x plus 50y is less than or equal to 600. Since I found my x-intercept and my y-intercept, I could draw my line through those 2 points. Let's go to my second equation. My second equation, if I plug in 0 for x, I'm going to get 6y is less than or equal to 60, so then y has to be 10. That's my y-intercept. If I plug 0 in for y, 3x is less than or equal to 20, so 3x is less than or equal to 60, so x is less than or equal to 20. My x-intercept is 20. So I get my red marker, and my y-intercept is 0, 10. My x-intercept is 20, 0. I want a red line. There's my red line. And that's what my problem looks like. Let me make that a little better line, like that. So remember, I wanted to maximize. My objective function I wanted to maximize. So at this point, I need to find my critical points. So since I'm maximizing this, since I have here less than or equal to 600, less than or equal to 60, the area that they share, by the way, I also have greater than or equal to 0 and greater than or equal to 0 down here. The area that they all share is what I am shading in blue now. This four-sided sort of triangle, sort of not triangle, is what they have in common. Since it is a bounded region, what I need to find are my critical points. So in black, my critical points are going to be this intercept, this intersection, this intercept, and here where my x and my y come together. So this intersection here is the coordinate 0, 10. This intersection here is the coordinate 8, 0. This intersection here is 0, 0. And then the last one that I need, I can actually read it off my graph, or I can go ahead and set my two equations equal to each other and solve for x and y. I get this intersection point here to be 2, 9. And there's several ways that you can find that intersection point. If you don't remember how, we can go ahead and do that. So those are my critical points. Those are my critical points. So let me go ahead and clone 0, 10, clone. Ooh. Don't move that. Let's undo that. Okay. Oh, I cloned the dot as well. 2, 9. And these 2 points are coming together. 0, 0, and 8, 0. Those are my critical points because those are the vertices of where my intersections of my constraints come together. Substitute the values from the critical points into the objective equation. My objective equation was S is equal to 12x plus 18. Why? I've got 4 points to check out. I don't like this one. It looks kind of ugly. Let's go ahead and rewrite that as 0, 10. Then the other one was 2, 9. Then 0, 0. And 8, 0. So I'm going to plug each of these into my equation, my objective function, and I'm going to see what it gives me. So 0, 10, if I plug in 0, 10, S is equal to 12 times 0 plus 18 times 10. Well, this cancels, and so this is 180. My next, so 180 feet cubed, that's the amount of storage capacity that it's giving me. Then I need to draw my next one. My next one is 2, 9. So S is equal to 12 times 2 plus 18 times 9. 12 times 2 is 24. 18 times 9. I need to grab my handy dandy little calculator. I'll be right back. So 18 times 9 is 162. If I add those together, I'm getting 186. Again, this is storage capacity, so this is cubic feet of storage capacity. My next critical point is 80. So this is 12 times 8 plus 18 times 0. This goes away. 12 times 8 is 96. So it's 96 cubic feet. And lastly is my 0.00. But again, I'm looking for here for maximizing the amount that I can have. If I go S is equal to 12 times 0 plus 18 times 0, well, that's going to give me a storage capacity of 0. I don't really, I mean, I can say 0 cubic feet. It doesn't hurt to find that. But I know that's not going to be the maximum. That is the minimum, but that's not the maximum. And so for this problem, since I was trying to maximize, I don't really need to think about 0, 0, but it's nice to see that it's there. So what's my conclusion? Well, if you look at what's in green, I have a maximum storage capacity of 186 feet cubed. So we maximize our storage capacity or storage space of 186 cubic feet if we purchase 2 cabinet A's and 9 cabinet B's. Understanding, but since we did the constraints, we know that buying 2 cabinet A's and 9 cabinet B's, I am not going to go over my $600, and I'm not going to go over my 60 feet, because that's the whole purpose of putting the constraints in. Hopefully that does make some sense. We will do more of this in class. Good to see you. Have a good evening.